Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle, and it's called Yin-Yang Territories by Macetab. And here are the rules. Sudoku rules apply. Fill the grid with the digits 1 through 9 so that each digit appears exactly once in every row and column. This is not exactly normal Sudoku rules. It's actually Latin square rules, where basically you have... Is that Latin squares? Where basically you have the digits 1 through 9 in every row and column, but there's no regions to actually fill the digits with 1 through 9. We have yin-yang shading, where we need to shade some cells such that both the shaded and unshaded cells are orthogonally connected. And no 2x2 square is either fully shaded or entirely unshaded. Let's come up with a valid yin-yang shading. Could have something like this. I think that works. Nope, it has to go to here. So this is an example of a valid yin-yang shading. Okay, some shaded cells are already given given in gray. So that means those are shaded cells. So that's why I had to make this this sort of shape. And to get to this shade, so what does it mean to have all the shaded cells and all the unshaded cells are orthogonally connected? That means you can go from any shaded cell to any other shaded cell just by going through edges, all while staying within the shaded region. So, for example, to get from here to here, you would have to go through these edges here, and that would show that that's valid. And you could do that with any two cells that are shaded. And you could also do that with any two cells that are unshaded, because you can go from any cell in the unshaded region to any other cell in the unshaded region just by going through edges, all while staying within the unshaded region. This is not a valid shading here, because to get now the unshaded cells, to get from these unshaded cells to any other unshaded cells, you could not, or to these unshaded cells or these unshaded cells, you could not go through just edges, all while staying within the unshaded region. You would have to cross either through a corner or to the shaded region, which is not allowed. So we have yin-yang shading. That's an example. Oh, another way. Also, this would not be a valid yin-yang shading because we have a 2x2 area, which is all unshaded. This would also not be a valid yin-yang shading because we have a 2x2 area that's all shaded. And you cannot have a 2x2 area that's all shaded or all unshaded in yin-yang shading. We also need to divide the grid into regions consisting of orthogonally connected cells, such that every cell belongs to a region. Each region contains exactly one circled cell, and the number inside the circle gives the size of its region, and no digit may repeat within a region. So, every region and in addition, each region must consist of entirely shaded or unshaded cells. And all shaded regions have the same digit sum, and this common sum is not given and must be deduced. So I actually did a previous version of this video outlining the rules, and in that I stated that the shaded cells have to sum to a digit. because of the phrase the same digit sum. But I think what they're meaning is that the digits must sum up to a certain sum. And that sum could be any number. I don't like the way that they phrase this. This is not the same digit sum is a very ambiguous way of putting things. It implies that it could be basically the sum of the digits, in which case you should be saying all shaded regions, all shaded regions, their digits sum up to the same sum. Or if you're implying that it is the same digit that they're summing to, you should say all shaded regions sum up to the same digit. But the same digit sum is very ambiguous, right? It could be the same digit sum, where basically it's the sum of the digits, or the same digit sum, which is implying that the sum is a digit. So the problem, I don't like this phrasing because it's ambiguous, but I basically tried figuring out in the early stages. I figured out immediately there's no way that the sum of the shaded regions can sum to a single digit, and I'll explain later in my solving of that why that's the case. So that means this is the sum of basically the digits in a region must have the same sum for shaded regions. So, again, I would like to see this clarified better. All shaded regions their digits sum up to the same sum, or in all shaded regions, they have a sum summing up to a digit. And I think it's the former. It's the first one, where basically all the shaded regions, the sum of their digits sum up to the same sum. And I'll show you again when I'm solving this why I came to that conclusion, that it cannot be the same sum being a digit. This common sum is not given and must be deduced. So we don't know what the sum of the shaded regions are, and we have to deduce them. But, so each region, again, must consist of entirely shaded cells. So let's give an example of one. We could have something like, say, this, right? This would be an example of a shaded region. It would be size 5, so therefore this would be 5. And all shaded regions would have to sum up to the same sum. So whatever this region has as digits, if they add it up to a sum, then all other shaded regions must add up to that same sum. So that's an example of how these regions and these circles exist, right? Again, every region has a circle in it, exactly one circle, whether they're shaded or unshaded, and they must all be fully shaded or all fully unshaded as a region. And they're orthogonally connected, so the things that I talked about orthogonally connected shaded cells and unshaded cells also applies for the region. You must be able to go from any cell in a region to any other cell in a region just by going through edges, all while staying within the region. And that's an example of how these Yin-Yang territories are going to work. We also have a blue dot between two cells indicate they belong to different regions. So that means these have to be different regions, but does not mean they have to be different shadings, right? So this would be valid here. I guess we could make this a region and this a region here. So that would be an example of how these regions could exist. So that's how the blue dot works. We have also one white dot, where a white dot between two cells indicates the digits in those cells are consecutive, and not all dots are given or are necessarily given. So say this was a 6, this would have to be 5 or 7 to be consecutive between these two digits. But there's nothing saying anything about having a digit having a border between these. So these are not necessarily in different regions. They could be in the same region here. And that's an example of how the white dots work. And finally, we have an arrow outside the grid gives the sum of the digits along the indicated diagonal. So, for example, these two digits must add up to 7, and these two digits must add up to 7. So say this was a 5 here, this would have to be 2. And say this was a 1 here, this would have to be 6 then. Because these two digits must add up to 7, and these two digits must add up to 7. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so how did I figure out that basically the shaded cells could not sum up to a single digit? And the answer is we have a shaded cell here, which is 7. It has to be part of a region that reaches a circle orthogonally. The minimum here is 3 cells. So 7 here, it's 7 here, 7 here. But that means it's guaranteed to have 7, 1, and 2 in it, which is guaranteed to be larger than a single digit. That's part of the reason why I knew that this could not be the same. It could not be summing to a singular digit, which is why I had to redo my video before, because I assumed which actually kind of improperly. But the problem was that this rule set is very ambiguous, because it could be the same digit sum or the same digit sum, right? So again, that's the reason why I don't like this explanation of the rules, because it basically is ambiguous about how you could interpret that. I don't like ambiguity in rules, so that's part of the reason. And also that's why I don't like not all dots are given. Well, you could... That's actually a different... that's a different thing. I usually like not all dots are necessarily given, because usually that information isn't important. That not all dots are given specifically is important to the solving of the puzzle. It's usually not all dots are necessarily given is important to the puzzle. But having that actually, that is ambiguity, right? It could be an ambiguity of how you try to solve the puzzle, right? And you might actually have a portion where not all dots are given is important to the solving of a puzzle. But you have that ambiguity there, where is it actually an important rule that not all dots are given, right? By saying not all dots are necessarily given, you know that basically there could be consecutive digits somewhere in the puzzle, but you don't know if you do know that it's not important that every dot is not given, right? It's basically usually shorthand for I didn't want to basically give you too many dots, because first of all, it would make it to solve too easy, and second of all, it's trying to figure out where all the combinations are when it's not important to the solving of the puzzle would be kind of painful. But anyways, that's a digression. Also, another reason why I knew that there's no way that the sums could add up to a single digit is along the edges of yin-yang shading, you could only change at most... You could change change shadings at most twice. And the reason is, if you tried to shade here, and then shade here, and then you had these sections being unshaded, how do you orthogonally connect the unshaded regions and the shaded regions? To try to connect the shaded regions orthogonally, would necessarily break the unshaded regions into two separate regions, which is not allowed, right? It's supposed to be one singular unshaded region. And it's the same if you try to make the shaded regions connect. And this is a change of 1, 2, 3, and 4. You can only change shadings in multiples of 2. So that's why you can't have multiple shadings in multiple changes of shadings. You can't have more than 2 changes of shadings in... Actually, I guess I should put it another way. You can only have either 0 changes of shading on the edge of the grid, or 2 changes of shading on the edge of the grid. Because if you try to have more than 2, well, you can't have odd changes of shading, right? How does it change shade once and then not again? It can't. So if you try to have odd changes of shading, that doesn't work. If you try to have more than 2, that doesn't work either, because that breaks the unshaded regions and the shaded regions into 2 regions, either for the shaded regions or for the unshaded regions. Did I say let's go? I don't even remember if I said that let's go. I'm assuming that I did. But yeah, I'm a little discombobulated right now. Anyways, so that's the reasoning also. So then that means the shading has to either be all this way connected or all this way connected, because you can't change shades more than twice. You can only change shades 0 times or 2 times on the edge of the grid. And that necessarily means there is a 9 in one of the shaded regions. Well, 9 can't be by itself in a circle, because it has to have 9 other cells in that region, because the circle counts the number of cells. So even if it's a 2-cell region, it's 9 and 1, which is guaranteed to add up to greater than a digit. So that's the reason why we knew that what they said of all shaded regions have the same digit sum. It's the sum of the digits which are the same. And it's not a sum that is the same digit. So that's how we knew that. So we have a common sum, which is the same sum for all shaded regions. Again, we can have shading going this way, at least, or this way, at least. If it goes this way, that's interesting. So I'm going to be marking it gray, I guess, because these are all gray already. What does that mean? Okay, so first of all, let's mark in all the boundaries of regions. Here, 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 and here. Okay, so say we had the shading be this way. Another thing we have, though, is these must add up to 7, so it's 1 through 6 here. I need to figure out how many circles do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So 3, 7, 9, 11, 14, 16, 19, 22. So we definitely have 22 regions, which are the Yin-Yang territories. 22 territories. Huh, that's another thing that's interesting. We have 5 in a column. And we have 3 in a column. The sum of these circles must be 9 times 9, which is 81, because that's how many cells we have. We have 22 territories. So what are the minimum values here? We have 1, 2, 3, so that's 6. We have 1, 2, 3 here, that's 6. We have 15 here. This is 3 at most. Oh, sorry, 3 at least, 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 and 3 at least. That's plenty. That's 21. And 21, which is 42. Okay, so that's fine. What about if we try this way? This is 6 plus 10 plus 3, 3, 6. So 3, 3, and 6. 3, 6, and 6. That should be plenty too. We have 24 plus another 6, which is 30, 43 minimum. Okay, so that's not going to help us. Shading, we're guaranteed it's all shaded either this way, or just entirely around the grid, or some subsections thereof, right? What happens if it's all shaded there? Well, that's interesting there, right? So if this is all shaded, that means this must be unshaded, unshaded, unshaded here. This is unshaded here. This would either be 1 or 2 here, to be because you can only have. So this would, okay. This would necessarily be, okay. Right, we can put boundaries between circles that share an edge. Right? So because either they're different shadings, which means there's a region border, or they're in the same shading, but again, every region has to have only one circle. So these are boundaries necessarily. This is a boundary necessarily here. This is either, it can be 1, 2, or 3. So this cannot be 4, 5, or 6. So this must be 4, 5, or 6 here. Since this is 4, 5, or 6, that means these 3 cells are the same boundary, or the same region. Therefore, this has to be a different region than that circle. So if this is 4, this is 3, so this would have to be 3 that way, and it would have to be 4 that way. Otherwise, it's more than that, so it has to go to at least here. So this is the same region, guaranteed. If we have 3 here, this must be 4. If otherwise, this is 2 and 5 or 1 and 6. It could be 5 going this way or 5 going this way. Or 5 going that way. Uh... Oh, that's interesting. We know that the shaded regions must sum to a 2-digit number because it can never be a single digit because it includes a 9 guaranteed. And again, the same thing that we said about this is 7. So it can never be the full 9. So you can never have in the shaded regions a 9. Actually, how many digits can you have? Um, well, this could be a region of 1. That is certainly possible. This is guaranteed to be the same region. This could go out that way. Oh. Interesting. This is limited as a region too. Well, not necessarily. Huh. One of these is limited as a region, right? But the other one is not, because it can go far, right? So either this is at maximum 3 here, if this is a certain region. So if this is greater, I mean, they can both be small. That's possible for both. This is very can be 3 at most also. So this could be 1, which means that's 6. This could be 2 or 3, but that's it. So this cannot be 1, 2, or 3. It's 4, 5, or 6. If this is 3, it would have to be these 3. So then this would have to be 4 going down that way. And it could go 3 there, or 4 there, or whatever. So we're only guaranteed these cells are part of that region. So there's definitely a border there. Interesting. So this pink region goes there. This then has to be 1 or 2. Or this is 1 or 2. Right? So one of these is guaranteed to be a 1 or 2 at least. At minimum. Or sorry, at maximum. Right? Because either this blocks that. So obviously they both could be 1 or 2. But if this were 3, it necessarily has 3 digits there. That forces that to be a 2 there. If this is 3, that would block this, and this would be 2 at most there. So we have a guaranteed one of these is 1 or 2. Sorry, I was shaking. One of my commenters basically said that they didn't like when the camera was shaking, and I think I might have been shaking. I tend to, I don't know. shake my leg a little bit sometimes. I don't know. Maybe it's just for circulation or something. Just it's unconscious, and that sometimes shakes the tables. So I just need to stay away from the table from shaking it because otherwise I'll shake the camera if I do that. Um. Anyways, let's continue. Um. Huh. That's interesting. Oh. This is guaranteed to be 1 or 2. Huh. That is fascinating. Right? Because it can go up at most there, and then it's blocked by other circles. So say we did have the shading go this way. If that's the case, this again cannot sum to a single digit. Because we are guaranteed to have a 9 somewhere in these puzzles. And the 9 would have to be with a 2. So then this has to be 2 and 9, necessarily. So that means this is a region. All the shaded regions would have to add up to 11. So there would have to be a 9 somewhere here with a 2. So therefore, this would be 9 and 2 guaranteed as a region. And every time you have a 9, so you could have a non-9 here. This would be unshaded, unshaded, unshaded here, and unshaded here. All the region sums have to be either 4 at most, or, yeah, 4 at most to add up to 11. And so this would be 4 then. But the problem is 4 cells in a region. Right, that doesn't work. This doesn't work because 4 cells in a region requires that the digits be 1, 2, 3, and 5 to add up to 11. So therefore, this can't work then as this shading. So the shading cannot be, because this is guaranteed to be 1 or 2, this cannot be shaded. This has to be unshaded. I usually use unshaded as green, though. So, so this is a region. This has to be unshaded. That means this must be shaded here, guaranteed. So that's interesting. Here you could... Okay, so this is unshaded here. Here you could have 2 and 9. No, but then that would be 4, and you'd have the same problem. So it cannot be 2 and 9, therefore it must be at least 3 cells. So you have 3 cells here, which add up to the same sum. So this is 4, this is 4. So now we have a region here of shaded cells. This is a region here of shaded cells. This must be at least 3 or 4, because 2 as a region doesn't add up to the same sum. So this has to be at least 5. So that means this region goes at least here. And this must be shaded, so this is unshaded here. It could go that way, we don't know. This is blocked from a region, so this is 1 or 2. So this is at least 5 as a region. To add 3 can only add up to 20 at most. 6 would necessarily have to add up to 21. So therefore, they can't add up to the same sum, so therefore this must be a 5. So 5 adds up to at least 15. This is 3, so this must be all the same shading and is a region. So then this is done. This is 1. Therefore, this must be 4 and is unshaded. So this is all unshaded here, guaranteed. And the region is here. So then we can remove the red coloring and the pink coloring because we know what those regions are. This is 1. This cannot be unshaded. If this were unshaded, again, because we have the reason why we know all of this is unshaded is this cannot add up to the same sum for the shaded regions. Also, well, could be 8, 9, 8, 9. That's fine. But basically, this can't add up to the same. This can't add up to the same sum as these because that would guarantee it has to be 2, 9. But there's just no way that 4 unique digits here can add up to 8 and 9. Therefore, this has to go either there. Okay, so this is blocked off. It cannot cross to another circle. It cannot cross to this cell here because that's shaded. Just make sure that I didn't make that shading. I did not. So therefore, this is at most 4, and it cannot be 1, 3, or 4. It's 2. So this is size 2. This has to be at least 5 here, then. So this is at least 15. This is at least 15 because this is 5 digits. Oh, you can't have, well, we could have 6 digits for unshaded regions. So to add up to at least 15, that means the other 2 digits must add up to 12. So that means we are guaranteed this is 4 through 9 here, 4 through 9 here, 4 through 9 here, 4 through 9 here, and this can't be 4, 5, no 4 here, no 4 or 5 here. This digit cannot be 5, cannot be 1, 2, 3, or 4, so we're guaranteed this is at least a 6. 1, 2, 3, 5, 6. Adds up to what? 6 plus 6 plus 5, which is 17. So that means these must add up to at least 17. That means they must be at least 14 for the remaining digits, which is 5 and 9. 5 is the lowest digit. This must add up to 17 at least. Interesting. It cannot have 1 and 2 here. Because 1, 2, 4 adds up to 7, plus 10 adds up to 17. 10 is not a digit. So this must be 1 or 2 here. We obviously have to have 1, 2 with 6, 8, or 9 here. 6, 7, 8, or 9. So this is guaranteed to be 1 or 2. If this is shaded. Okay, so then we cannot have this be shaded, shaded, or the region, 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 region. Oh, also this is unshaded because of the shading. So this is necessarily a border this way, which means this does have to go this way. And then it could go 1 or... So this is boundary here. And it has to go either here or here. We're not sure which. You cannot have 6 and 7 because you would have 5, 6, 7 plus 1 and 2. That adds up to 21, which 3 plus 2 other unique digits can never add up to. So this must be, so this is either, can it be 9? 5, 9, 1, 2, 3 does add up to 20, so that could be possible. So this could be, this is specifically 6, 7, 8, 9. The remaining digits in this row are 5 through 9. So this must be 1 through 4 here, guaranteed. Because it cannot be 5, and it cannot be greater than, it cannot be 6 or 7, because that would necessarily force this to be 6 or 7. Hmm. So this is guaranteed to be 2. This adds up to at most 20. Oh wait, no, this is unshaded, so it doesn't have any restrictions there. This must be unshaded. Okay, so this is unshaded here because the yin-yang shading has to orthogonally connect to each other. Therefore, this is boundary there, which means this is the full region here. And again, this must be 1 through 4 to add up to 20 at most for the shaded regions. This must be unshaded, so it has to go that way. This then must exit out for 5 or 6. Or actually, this could be 5 through 9. So it's at least 5, which means it has to go at least this way. So this is all unshaded. This blocks that way. So this is at most 20. It could be 30. Okay, so 7 eliminates 7 here. This is all unshaded and is part of the same region. So therefore, this is blocked here. So if this... That's interesting. Huh. This is shaded. It could be part of that cell, maybe. All shaded circles must be from 3, 4, and 3, 4, 5. So that's interesting too. So this is a shaded cell. It goes to either here, here, or here. We could have 4 and 5 here. This we don't have any restrictions on. Obviously, okay, so what's the minimum? Okay, so we know this is at minimum 1, 2, 3, 5, 6, which is 17. So say this was 17 here. You'd have 17 plus 2, 5, and 3. That's 10. So that's 27. $27. I don't think works. No, 20. So 45 minus 27 means the other two digits must add up to 18, which is impossible because two unique digits adding up to can only add up to 17 at most. So it cannot be 17 here. This must be at least 18. So 18 plus 2, 5, and 3 is 28, and then you could have 8 and 9, 8 and 9 there. Oh, what happens if this is 20? So if this is 20, this must be 8, 9, 8, 9 as a pair. And that doesn't work. So you have 8, 9 here, 8, 9 here. This would be 4, 6, and 7, which would mean, but that doesn't add up with 1 or 2 to add up to 20, right? That adds up to 19 at most. So you can never have 20 be the sum. So it's either 18 or 19 is the sum. If it's 19, this is necessarily a 7-9 pair. So this can never be 1, 2, 3, 5, and 9. So this is 6, 7, or 8 here. If we have 19, it's 3, 7, 9 here, 3, 7, 9 here. So this would be 3, 7, and 9. So how would that work? 3, 7, and 9. That would force this to be 9 and 7. So this would not have 7 or 9 here. It would have to have 6 and 8 with 1 and 4. That adds up to 19. So this would be 2. So that seems possible. So you cannot have... So it's 18 or 19, so you cannot have a 5 in either set. So if it's 18, it's 3... Okay, if it's 18, this is 18 here. Which would mean it has to be 4, 6, 7, 1, right? Because you can't have 1 and 2 here. Yeah, I think it's... Okay. So that's interesting. So if it's 19 here, these add up to these two digits must add up to 16. These two digits must add up to 16. Okay, so let's go through the okay, so we know what those are then. Then this has to be 7, 9 as a pair. This is 7, that's 9. This would be 6 and 8, 4 with 1, and that would be 2. If it's 19, sorry, if it's 18, this adds up to 18, and it can only be 1, 6, 7. Which would then force us to be at 8 and 9 pair. But this can't be 8 because that would force us to be 7 because of 7 in the column. So then this would be 9. So the possibilities are this is 7 and 9, this is 7 and 9, and then this becomes 1, 6, 8, and this is 2 to add up to 19. Or to add up to 18, this is 18, it can only be 1, 6, 7, which would force this to be 2 either way. This would have to be 8 and 9 as a pair, so then this would be 8, which would force this to be 7. So either way, we're guaranteed a 7 in one of these cells. This would be 8, this would have to be 9 and 6, and we're guaranteed one of these is a 9. Again, this cannot be 9 here, because if we had a 9 there, that would be 5 and 9, with 1, 2, 3 at minimum, which adds up to 20. So this is guaranteed to be 2 here, which means 2 cannot be in the rest of the region because there are no repeats in regions. So again, the sum of the shaded regions is either 18 or 19. And either way, it leads to this being 2. Can you have 5, 2, 3, 4? I think the answer to that is no. Yeah, 2, 5, 3, 4, 6 adds up to 20. So you're guaranteed a 1 here. So 5, 2, and 1 add up to 8. So it could be 3 and 8 adding up to 11, which would make that 19. 3 and 7 adding up to 10, which make that total 18. Or 4 and 7 adding up to 11, which makes that total 19. 4 and 6 adding up to 10. I don't think this can ever be 6. If this is 6, again, it can't be 3 and 6. 1, 2, 3, 5, 6 only adds up to 17. And if we have 1, 4, 5, 2, 5, 6, that adds up to 18, but then this must add up to 18, and it has to be 3, 9, and 6, which would mean this can't, so this can never be 6 here. It's 7 or 8. Okay. This must go in a shaded region here. So again, the shaded region is part of either that, or that. This is limited as a region too. It can be at most 4, right? Because it's blocked off here, necessarily, if it includes this cell. So this is up to 4. It could be 1, 2, or 4 here. If it's 4, it's shaded, and then this must be unshaded. If it's 1, then that means this is green, which means the rest of this is green, which is possible. Oh, this can't be 4. If this is 4, that would necessarily force this to be 1, but we know we have a guaranteed 1 here. Oh, so this can't be 1. So then this has to be shaded, I think. So this cannot be shaded. Because again, can't be 4 because that would force this to be 1. We have a guaranteed 1 here, and that's not possible because this is 2 shading going that way. So then this has to be unshaded, so all the rest of this is unshaded. Which means this is shaded, this is shaded. This cannot be 1. It could be up to 3. Or... So this... If this is unshaded... If it's shaded, it has to be 3, 4, 5. Right? If it's unshaded, it cannot be 1. This would have to necessarily go here. This would be 2. So this would have to be 2 then also, if it's unshaded. But that doesn't work. So say we have... Okay, so we have this exit this way. This can't be 1. This has to go 2 that way or this way. This then must go 2 that way or that way. And that would form a 2 by 2 square that's all unshaded. Right? It can't be shaded and this be not part of the region. Because then it would be 2 at most here, and you'd have the same problem. So this has to be then shaded, which means it can't be 2. It's 3, 4. Cannot be 5, because one of these is 2. So it has to be at most 4. Cannot be 5. This is 3 or 4. We have a 1, 3, 4 triplet now in row 3, which eliminates 1, 3, 4 in the rest of the row. So that remaining is 2, 5, 6, 8, 9. 7, 9. Obviously, 7 can't be here because of 7 in the row. 2, 5, 6, 7, 8, 9. No 2 here because of 2 in the column. 2, 5, 6, 7, 8, 9. This is at least 2. So if this were unshaded, it would have to go out this way. And there would be 2 by 2 area that's all unshaded. So this must be shaded. So this cannot be 2. It must be 5 here then. So this is 5, which eliminates 5 in the rest of the row. So this cannot be 5. Can it include the 7? It could include the 7. That is possible. The green has to orthogonally connect, so this is green necessarily. Oof. We don't know what this is. It could be many things. We don't know what this is. It could be many things. There's no restrictions on the unshaded regions. This must be region here. So that's 1, 2, 3 guaranteed. Could be part of 4. Could certainly work there. This has to be part of the region. If it's not part of the region, then it has to go around, but then it would have to go around here. And therefore, this would be a 2 by 2 area that's all shaded. So this is all part of the same region. Oh, obviously this is not. What would the minimum be here if this were all the region? If this were the entire region, you would have guaranteed 1, 2, 4, 5, 7. 5 and 7 is 12. 1, 2, 4, that could work. That adds up to 19. Yeah, that could be fine. Except that this has to be 3, 4, 5, and we know this is 4. So this must then extend this way. So one of these is shaded, which means the other one is unshaded. So this must be a boundary here. Because if it's all 5 going down that way, it's now 1, 2, 5, 6, 7, which adds up to 21, which is not possible. You can't have 5, 7, and 6. Obviously, this is boundary here. This is boundary here. So I think this has to be a 1, 2 pair, right? Yeah, 1 and 6 is too large. 5, 1, 6, 7 is already 19, and we have another digit. So therefore, it's 1 and 2 guaranteed here, which means the rest of the column has to be 6, 8, or 9. So this is 6, 8, or 9. So 5, 1, 2, 7. What does it add up to? That's... Wait, then that requires another 5. That's not going to work. Oh, wait, no. 3 or 4. What am I thinking? It's not 20. So this is 8 here plus 7 is 15. So then plus 3 or 4. So we're guaranteed a 3 or 4, whichever one, but we don't know which one that is. We do have a 1, 2 pair in row 4 now, which eliminates 1, 2 the rest of the row. So this must be 3 through 9 here. This must be 3 through 9. This is 3, 5, 6, 7, 8, 9. Hmm. Hmm. Huh. What else do we have? Hmm. We do know that this has to be... Okay, so this must be... Okay. At most, you could have 1, 2, 3, 4, 5, 6. So we know this is all the same region. Sorry, at minimum, you have to have 1, 2, 3, 4, 5, 6, and this can't be part of that region because then that would force shading here, and this would be a 2x2 area that's all unshaded, right? So that's why we had 1, 2, 3, 4, 5, 6 is possible. So this is all the same region. That doesn't really help us much, actually. We don't really care too much about the unshaded regions. It's really the shaded regions which are interesting, because the unshaded regions just need to have basically no repeats. That's all. Hmm. So this is guaranteed to have a 6 here. It doesn't want to tell us much, but okay. It's either 167 or 168. Oh. Wait, hold up. I think this could be... That's not right. Something's not right with this situation. Okay. I'm pretty sure that this is correct, though. Okay, again, adding up to 19. This must be 7 and 9 as a pair. That forces this to be 7. This is 9. This is 1, 6, and 8, adding up to 19 here. This is 9 and 7. So that's 9. I think that was where I messed up. If this is adding up to 18, this must be 1, 6, and 7 here. This cannot be 8. Because that would force this to be 7, which is not possible. So then this would have to be 9. This would be 8. And this would be 8 and 7, so this is always 7 here. Okay, that's good to know. So this would be 7, 9 with 6. So this is 8 or 9. Okay, so yeah, that was the problem. So this is 7, guaranteed. Which eliminates 7 in the rest of the row. Okay. Hmm. This can't be 4. It's, well, yeah. You can't have 3 shading here and then this be a separate shading here. So this cannot be 4. If it's 4, that would force this to be 3, 3, 4, and another digit is never going to add up to 18 or 19. Same with this being 3, actually. Well, 4, no, it could be 4, 3. If this is 3, it could be 3 that way. It could be 3 this way. It could be 3 that way. So that's pretty broad. If it's 4, it has to be these 3. If it's 4, these are all shaded. Ah, that doesn't work. So if this is 4, this has to go this way because it can't be a 2x2 block. So it must include that, which means it goes this way. This has to go 2 down that way. But then this is unshaded and it doesn't connect to the orthogonally connect to the rest of the unshaded cells. So this cannot be 4. This is guaranteed to be 3. So this is 3, which forces this to be a 1-4 pair here. So this is a 1-4 pair here. That means we have 1, 2, 4, 5 adding up to 12. This has to be 7. So these add up to 19, which eliminates 7 here. This is 3, 7, and 9. This is 3, 7, and 9. This must have 3, 7, and 9. So 7 has to be... These can't be 9. So it cannot go up this way. So, oh, this 3 eliminates 3 here. It has to be 7 and 9. So this is 7 or 9 here. And you could go 3 that way, or it could go 2 there. This 9 eliminates 9 in the rest of the column. So this adds up to 19. No 7 here. It's 1, 6, and 8. This is 1, 4 as a pair. Again, we try to have 1, 4, and 6. But that requires this to be 3, 9, and 6 there, which doesn't work. This is 3, 7, 9. So it cannot be here. So this is a boundary, which means it belongs to one of these 2 cells, and therefore is shaded, or sorry, unshaded. Okay, this cannot be 3 going this way. If it were, the problem is that then you'd have a diagonal here. So this is the other part of Yin-Yang shading, which you can deduce. You cannot have a diagonal that's one shading and the other diagonal be the opposite shading. And if this were shaded here, this would have to be unshaded. So you have that situation. Well, how do you orthogonally connect the unshaded region without breaking apart the shaded region? And the answer is you can't, right? In any way which you try to orthogonally connect the unshaded region, it will necessarily break apart the shaded region into 2 regions. And if you try to orthogonally connect the shaded regions, it's the same problem with the unshaded regions there. You would break that apart into 2 cells. So this cannot be going that way, which means it must be going this way. This is a 2x2 square that's all shaded, so this cannot be shaded. It's unshaded. Therefore, this must be 3, 7, and 9 that way. So this is 3, 7, and 9, which eliminates 9 in the rest of the column and rows. So no 9s there. This is done as a region. Okay. This is 2 going that way, so this is unshaded. Sorry, that's a region. Could be 5, 6, 8. We don't know which. This could still be 2. It could be 1. This could be many things. There's not as many restrictions here. This 7 eliminates 7 here. This can't be 1, 2, 4, or 7, so we have 3, 5, 6, 8, and 9 there. Okay. So this adds up to 19, which means we have a 4 guaranteed in one of these two cells. Okay, this can't be 1, 2, 4, or 7, so we have 3, 5, 6, 8, and 9. No 5 here because of 5 in the column. Um, uh, this must go to a region that's shaded. Huh. Hmm. What do we have so far? 4, 3, 5. I don't think we're going to be restricted by the sum of the digits. Um, hmm. This can't be 2 or 7, so it could be 1, 3, 4, 5, 6, 8, 9. This can't be 3 or 7. It's 2, 4, 5, 1, 2, 4, 5, 6, 8, 9. This has to be, can be 1, 3, 5, 6, 7, 8, no 9. 1, 3, 5, 6, 7, 8. This is 1, 2, 4, 5, 6, 8. That's basically the entire column. No 4 here because of 4 in the row. Uh-huh. Hmm. Oh, this is all unshaded, so therefore this can't be unshaded, it's shaded. That means it must be 3 or 5 here. Huh. This then has to be part of the same region, so it's 2. That forces this to be 1, which forces that to be 2. 2 eliminates 2 in the rest of the column, so no 2 there. Can this be 5? Yes. It can't go out further than this. But it could do like that. That is possible. Hmm. Could do that. Could do that as 3. Could do that. Could be here. If it's 3, it must be with 7 and 9. One thing it cannot be is 5, and this is a separate region. So if it's 5, it must include this, because if it's 5, and then this is not part of the region, it can't extend further here, can't extend here, because these are circles, and these are unshaded, and therefore this 2x2 area would be all shaded, which is not allowed. So if it's 5, it includes this, so then it would have to do something like that. But it's not guaranteed that this is 5. This could be 3. Oh, if it is 3, though, one of the digits has to be 7 and the other must be 9. Oh, how does that work? 7 can't be either of these. 7 can't be here. So it cannot be 3. If it's 3, it tries to go both cells here. That would have to have 7 and 9 here, which would be eliminated because of the 9 in the column. So it can't be 3 that way either because it requires 7 in the region, and 7 is not allowed in either of these cells. So this must be 5, which means this cannot be 5 here. This can't be 5. It must connect to here, because otherwise it would be a 2 by 2 area all shaded. So these are shaded, which means this cannot be both unshaded, so this must be shaded here. That means this connects this way. So this is all shaded, 3 shaded there, so this has to be unshaded. Therefore, this is part of that region, and this is a region here. How do you add up to 19 with this region? You cannot have a 2 in this region because of 2 in the row and 2 in the column. So what does that leave restricted? 1, 3, 4, 5, 6, which does add up to 19. So this must be 1, 4, 5, 6. 4 cannot be here, so this must be 4. This is 1, 3, and 6 here, which eliminates 1, 3, and 6 in the rest of the column. So this is 7, 8, 7, 8 as the rest of the row. 7 eliminates 7 here, so it's 8, which makes this 7. 4 eliminates 4 in the rest of the row, so this cannot be 4 here. To add up to 19, then, it has to be here. So this is not green, this is shaded. This is not shaded. So this is done as a region, and this must be 4. That eliminates 4 in the rest of the row. This 4 eliminates 4 here. This 8 eliminates 8 in the rest of the row. One of these at least must be shaded, and the other one must be unshaded. Because it must be shaded to connect to the rest of the green cells. And the other one must be unshaded because then we'd have 3 unshaded cells here, which means the last cell must be shaded. So this is also a green shaded combination. Let's see. 7 here. One of this must go to an unshaded cell in one of these. 1 or 2 here. Okay. One out of these 2 is unshaded. Can they both be unshaded is kind of the question. At least one of those 2 is unshaded. Okay, let's think about what possibilities. So if this is unshaded, sorry, if this is shaded, this is unshaded here. Oh, that's not possible. This has to be shaded. Or sorry, unshaded, because these must be part of a region. So this is unshaded here, so therefore this is shaded here. These 2 are shaded as a diagonal, so this cannot be unshaded because then we'd have the deadly pattern there. So this is shaded, which makes this 3 or 5, because it can't be 4. This has to be at least 4 in size, because it must include these. So this is 4, 5, 6, or 9. This has to connect orthogonally to the rest of the unshaded cells, so that connects that way. Hmm. That means this must be unshaded here, because if this is not if this is shaded, then this is blocked from ever orthogonally connecting to the rest of the unshaded cell. So this is unshaded. Could go down here. This digit cannot be 2, 4, 5, or 7. It's part of this shaded cell. Okay, so then this is 1, 3, 6, 8, 9 are the possibilities. Okay. Obviously, if this is 3, this is part of it, and it's 3, 9. And we would have to, we'd have to have 7, so the 7 would have to be here. So if it's 3, it would have to go like that. If it's 5... Okay, hold up. Can this ever be shaded? The answer is no. If this is shaded, this green has to go this way, but then this shading doesn't have a region. So this is not shaded, it's green. We have a 2x2 area that has 3 greens, so this must be shaded here to not make this all unshaded. This is a 2x2 area that has all shaded, so this can't be shaded. This is green. So this is at most 1, 2, 3, 4, 5, 6 cells. So this is 5 or 6. This has to go 1, 2, 3, 4, at least 5. So this is 4 or 5 cells. So this is definitely part of this region. This is boundary there. Here. This must orthogonally connect to the rest of the unshaded cells. It could do that by going down here or going down here. Either way works. This is kind of broad for what digits it could be. So this could be 597. That is possible. Sorry, 397. Otherwise it's 5, and you would not have these available. It would have to go out here. It could not go there. It could go something like this, though. Or it could go something like that. That is... No, it cannot go that way. So if we tried going 5 going that way, the problem is this has to be 4 as a region, and therefore it would be a 4 full, which would mean that this would then be all shaded, which is not allowed. Okay, so if we go shaded here, we have to go shaded here because then this would be unshaded. So either way, this is definitely part of that region and is shaded. So if either it goes this way or this way. If it goes this way, it cannot go this way, so it has to go that way, so this is guaranteed there. This cannot be 1, 4, 5, so it's 2, 3, 6, 7, 8, 9. Again, so if we had... If this was 5, how would that work? If this is 5, it would have to go something like that. It could not go a full that way, because then that would block this, and this would be a full shaded region of 2x2. So if we try going this way, the problem is this has to be 4 also. I guess that could... No. Cannot go shaded there and unshaded there. So if we tried having 5 here... Okay, so then let's see. This is unshaded because a 2x2 area is 3 shaded. Therefore, it must connect orthogonally. This has to connect that way, but this has to be 4 in size, and this can only go that way. And therefore, this 2x2 area would be all shaded, which is not allowed. So this must be 3. So this is 3, which makes this 9 and 7 there to add up to 19. That's done as a region. Again, it could go something like, no, can't. Okay, so if it goes here, that means this is unshaded because of 2x2 box, so it must go there. If it goes here, that means this must be unshaded because 2x2 box, and so it must go here. So it must always go here. This is guaranteed to be 3 that way. So the choices were to go here, here, or here. Obviously, if it goes here, then this is part of the region. If it goes here, that forces that. If it goes here, it forces that. So therefore, this is done here. This is 3. That means the remaining digits here can be 1, no 2, 3, 4, 5, 6, or 8. Okay. If we end here, we are guaranteed. We have to orthogonally connect to the shaded cells. So we would have to orthogonally connect either this way. Can this be unshaded? Maybe. This 3 eliminates 3 in the rest of the row. Where else do we go from this? These are consecutive. So this must be 1, 4, 5, 6, 8. That leaves this as a possibility 2 with a 1. 4, 3, and 5. 5, 4, and 6. 6, 5, and no 7. 8, and 9. Those are the possibilities there. Which is still pretty broad. Where is 7 remaining? 7 has to be one of these 2 digits in column 3. Or one of these 2 digits in column 6. Those are the only 7s possible. Okay. If this is 7, this is guaranteed to be... So this has to be 1, 2, 3. These are all part of the same region. This can't... Well... So if this is shaded, it has to be 5. So say what happens if this is shaded? Then this is 5 because it must add up to... This must be unshaded. This would have to be 5, and therefore it would be going that way, which is impossible. Because then the green cells would not be orthogonally connected. So this cannot be unshaded, so this must be unshaded. We have a 2x2 that is 3 unshaded, so this must be shaded here. That means this must connect to a shaded cell here. Because otherwise, it's just not going to... It cannot be part of this 4, and there's no other circle it can be part of. So then this must be shaded. This must orthogonally connect that way. So this cannot be 4, it's 3 or 5. It cannot be 7 here. That forces this to be 7 here, which means this can't be 7, so 7 is there. So we now have all the 7s. Can this ever be 5? I think the answer to that is no. If we have 5 here, we have to have it has to go this way, and then there, and that's a 2 by 2 area. That's all 5. So this cannot be 5. This is 3, which must be with 7 and 9. This must orthogonally connect to the rest of the shaded cells. So one of these is shaded, and it must be 4. It could go here and then here. Or it connects this way, and then one of these is fine. So this adds up to 11. Okay, so if we tried to connect this way, it must be 3, 7, 9 there. So one of these is guaranteed to be 9. But the problem is, if we have 3, 7, 9 here, that forces this to be 8. And it must orthogonally connect this way. 8, 4, and 7 already add up to 19. So it cannot connect this way. It must connect this way. So this is orthogonally connected. And this is a region. That means one of these 3. So this is 9. Which means this can't be 9 here. This cannot be shaded because it has to be, one of these has to be shaded. So this must be unshaded here. So one of these 3 is shaded and the rest are unshaded. Okay, this is 7, 3, 9. We have 4 and 7, which means, so this can never be 8 here. 4 and 7 add up to 11, so the other 2 digits must add up to 8. So it's either 1 and 7, which it can't be, 3 and 5, or 2 and 6. Well, 3, 2 cannot be either of these. 3 and 2 cannot be either of these. Therefore, this must be the shading and must be 2 or 3. Therefore, this is unshaded. That doesn't work. This is oof. How did I mess that up? Shoot. It has to go this way then. But that's not gonna work. How did I mess this up? Dang it. Right, these have to be part of a region. And this can't... So then it has to go that way, but then that's 9 and 8. What did I do wrong? I feel like most of this is correct. The problem is I made one bad assumption. I have no clue where this is. This is where basically the execution parts of these puzzles. Like, so the logic of this isn't too bad. The execution, though, is the problem part. Right? Shoot. Right, so... Shoot. Oh, it doesn't have to go down here. That's the execution part I messed up. This can connect this way. In fact, it sort of has to. Yes. Yes. Okay, so that was the bad assumption. So I assumed that it had to connect here. That's not correct. In fact, we've just shown that it cannot connect that way because this then is blocked because one of these cells has to be there. It cannot go 3, 7, 9 there. It cannot go 3, 7, 9 here because then these would not be part of our region, so it must go 3, 7, 9 that way. So this is 3, We have 7 here. This is 9. So this cannot be 9. In fact, it's only 1 or 2 in size. This could still be 9 and 8 technically. One of these is guaranteed. Okay, so if we could go this way. No, yeah. So we know this is green because it has to orthogonally connect, and it connects either that way or that way. This 7 eliminates 7 here, so this is guaranteed to be 7 here. Okay. This is at least 5. This is at least 4. So we only have 1 at most this way. So that would be 1, 2, 3, 4 at most. This can't be 3 or 4. It's 1 or 2. And it could be 2 and 2. This is at least 2, actually. Because this is part of that region. So this is 2. Which means this is 2. So these are regions here. Therefore, this is either 4 and 6 or 5 and 5. So this is part of that region. So it's really a question of these two. Okay. 2 eliminates 2 here. We have a 5, 6, 8 triplet in this region. And this is guaranteed. So this cannot be 5, 6, or 8. What can they be? So that cannot be 2, 3, or 7 either. So it has to be 1, 4, and 9. No, 2, 3, 5, 6, 7, 8. Yes, 1, 4, or 9. This can't be 4 or 9, so this has to be 1 here. This can't be 1, so it's 4 or 9 there. And again, these are all part of the same region. We don't know if it includes that or not. 1 eliminates 1 here, so this is 6 or 8 as a region. So this is full that way. 2 eliminates 2 here. So this can no longer be 1 to be consecutive. What can this be? This can be... So at most 1, 2, 3, 4, 5, 6, 7 in size. And then this would have to connect that way if that's the case. So this can't be 7. It's 1, 3, can't be 1, it includes that. So this is at least 3, cannot be 4, it can be 5, 6. So 3, 5, or 6 here. This is 4 and 7. So this cannot be 8. It cannot be 4, 7, 1. So again, the other two digits must add up to 8, which is 19 minus 11. So this has to be 5 and 6. And it must be 2 or 3 with it. So if it's 2, then it's these two digits, and that's a 2. So then that would be 6, 8, 6. That kind of works. What are the remaining digits in row 5? 3, 6, and 8. So if it's 3 and 5, this is 3 and that's 5. That seems fine. What are the remaining... So either this is shaded, or this is shaded. This can't be shaded because that doesn't add up to 19. This doesn't add up to 19 either. So again, it's 4, 7 with 2 and 6 or 3 and 5. The 2 would have to be here, the 3 would have to be here. So these are both shaded, so this is unshaded. This is unshaded. So this has to be, this could be 3. Can it ever be 5? I don't think so, right? If this were 5, then it would be either these 5, but then 1, 2, 3, 4, 5, 6, 7. Okay, so the problem is if it's these 5, that means this is shaded and these don't have a region. This is definitely part of that region, so 5 here would basically have the same problem, because this would be shaded, this would not have a region, so therefore this cannot be 5. If it's 3, it has to be these 3, so this is 2. If it's 6, it would have to include all of these, and then this would be 2. So either way, this is 2. So this is 2, which means this is a region that way. This cannot be 2 here. Whereas the 2 in row 3, or 3, yeah, it has to be here. So this is 2. So this is definitely, so it's 3 or it's 6. Can this ever be 8? 1, 2, 3, 4, 5, 6, 7, 8. Then that would force this to be 8 that way, and that doesn't work. So, because if this is 8 here, this must be 6 or 8, so it would have to be at least 6 here, but then this would force this to be shaded, and this cell would not have a region. So this cannot be 8. This is 6, which forces this to be a region there. So this cannot be 6. If this were 8 here, that would be 1, 2, 3, 4, 5, 6, 7, 8. But then that would force this cell not to have a region. So this cannot be 8. It's 6 here. So this is done as a region there, which means this cannot be part of... If this were blocked, this would not be these would not be part of the region. So this has to be blocked that way as shaded. So this is unshaded here. So then there's 4. This is 6. This is 8. No 6 or 8 here, so this can't be 9. This is 4, 5, no 6 there. We're guaranteed a 4 in one of these cells. This is then 4, 7, 6, and 2 to add up to 19. This can't be 3 or 6. It's 1, which makes this 6, which makes that 3. This cannot be 1 here, so it's 5 and 8, 5 and 8. 6 eliminates 6 in the rest of the column, so this can't be 6, this is 8. This can't be 8, it's 5. No 6 or 8, it's 3. This can't be 3 or 6, it's 8. So no 3, 5, or 6 here, so it's 9, which eliminates 9 here, so it's 4, which means this can't be 4. That's 5. That leaves this digit as 1. So this is done as a region here. We've all the regions then. We already knew this was a border. So this is 5 cells in the region, so it has to be here. This then is 5 cells in the region, so this is 5, which means this can't be 5, no 5 here. This can't be 3, so it's a 4, 5 pair, which eliminates 4 and 5 in the rest of the row. 5 eliminates 5 here. So this is 4, this is 5. That eliminates 4 here, so it's 1 and 4. This can't be 1, 4, 5, or 8, it's 1. This can't be 1 here. This can't be 1, 5, or 8 because of the 5, 8 pair in the column. This 5 eliminates 5 here, so it's 8, which makes this 5, which makes that 4. 1 eliminates 1 here in the rest of the column. So that leaves this digit as a 9. This can't be 9. So remaining digits in row 4 are 3 and 6. Well, maybe we can figure out from 1s. Not really. Okay. This is 3 or 6. Remaining digits in row 6 are 8 and 9. This can't be 9 because of 9 in the column, so this is 8, which makes this 9. 8 eliminates 8 here, so it's 6. This can't be 6 or 8, it's 1. 6 eliminates 6 here, so it's 8, which makes this not 8 because of the region, so this is 6, which makes this 8. This can't be 1 or 8, it's 6, which eliminates 6 here, so it's 3 and 6. Remaining digit in column 4 is an 8. Remaining digit in column 5 is a 1. Remaining digit in column 7 is a 5. That leaves this as 3 and this as a 9. And that's a solution. Yeah, execution-wise, definitely didn't work very well. For me, I didn't work very well essentially. um, Still a pretty fun puzzle though. Very interesting concept of the shaded and unshaded cells. Um, yeah, it just I made some bad assumptions. It was particularly this one was bad. What was the other bad one? I don't really remember. Um, yeah, it was interesting. Particularly like just basically figuring out where things had to be. But we didn't use like the sum of these at all. It was just basically what could it be, right? We did use the sum of the size of the shaded cells a lot. That was definitely very important. Um, yeah, I mean that works. It's basically a lot of the geometry I wasn't doing a very good job with. So, but either way, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.